We are going to learn about derivatives today. And actually, we pretty much talk about derivatives for the next few months. So definitely make sure you're taking notes on this video. I am going to show you what we call the definition of a derivative. So first of all, I'm going to tell you what a derivative is. By the way, this is not the definition of a derivative. The derivative is the slope of the tangent line So you might be saying, like, that's a perfectly good definition of a derivative. What else do we have? Well, in math, if you talk to a mathematician about the definition of the derivative, it's going to be a little bit more complicated than this. So I'll show that to you. So this is the actual definition of the derivative. So we have that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. You might notice that this thing that we're taking the limit of is the difference quotient. We've seen it before. I'm going to explain in just a second where we got that from. I will show you another way it's written. This is probably a less friendly way. You also might see it written with a delta x. This one, it's the same idea. Sorry, I'm running out of room. Except the h has been replaced with the delta x. If you go to college and you see it this second way, just know that it's the same thing. They just used a delta x instead of h. So I'm going to show you where this actually comes from. So let's say that we have a curve. And I am trying to figure out the slope of a line between 2 points. This point, I'm going to call the x value there just x. And I'm going to call the x value of the second one x plus h. What that means is that this distance right here is h. So then, if this function is called f, which we usually use for functions, then this y value right here is f of x. And then the upper y value is going to be f of x plus h. So remember that to find the slope, you do change in y over change in x. So I'm going to actually write these as points. So this point right here is x plus h, f of x plus h. This point right here is x, f of x. So then remember slope, we're going to do change in y over change in x. So I would do f of x plus h minus f of x. So that's my y1 minus, or my y2 minus my y1. Now I'm going to do x2 minus x1. My x2 is x plus h. My x1 is x. The only way to simplify this without breaking any math rules, so please don't break any math rules here, you can't do anything with those f's. Only way to simplify that is to subtract the x's. So x minus x is 0. In the denominator, I'm just left with an h. Okay, so here's where the limit comes in. What this thing I have right here is the slope of the secant line. So that's a nice start. However, the derivative isn't the slope of the secant line, it's the slope of the tangent line. So in case you don't remember, a tangent line is when you have one point and the line touches the graph in exactly one place. Secant line, you have 2 points and the line goes through those 2 points. So in order to change this secant line to a tangent line, what we want is we want the distance between these 2 points to get smaller and smaller. And actually, the way to get that distance really, really small is to take the limit as h approaches 0. So that's where we come up with that limit up there. You'll notice this is the same thing that we just got down there. That's our difference quotient, but it also is going to be the slope of the line. So this stuff I just showed you, I didn't tell you this before, you probably took notes on it, but I am not going to test you on it. However, I thought it would be good for you to see, first of all, this is a proof that you'll see in mostly any college level math class, and this is a college level math class. So I think it's important that you get exposed to it. I hope you understand it even just a little bit. You kind of get an idea where this comes from so that you're not just blindly plugging in numbers. But like I said, you're probably not going to be doing a lot of stuff related to what I just did. So don't worry if you don't quite get it. So before we do an example, I just want to show you a few different ways that you're going to see derivatives written. The first one is the one that you actually saw just a few minutes ago. This one we say f prime of x. That's what that little symbol up there, it's a prime symbol. So that one we're going to see a lot in this class. The other one we're going to see a lot in this class is this right here. So we actually, if you say this out, this is just pronounced dy dx. That's how we say it. The fancy way to say this is the derivative of y with respect to x. I'm going to abbreviate with respect to as WRT, by the way. You might have a college professor that does that. If you ever see WRT, it means with respect to. Okay, the other one that you're going to see quite a lot, and I like to use this one a lot because it's short and it's quick to write, is this one. We just say that this one is y prime. These three are the most common. So these are going to be the ones that you see the most in this class. You occasionally will see this right here. You'll see a dx of something like f of x or g of x or something. Occasionally you see that one. The last one I'm going to show you, you might actually never see this one in this class. In fact, I remember seeing this mostly when I got into my third semester of calculus. So this is pretty uncommon right now. But if you go on to study engineering or math or physics or anything else that requires you to take some more math classes after your first semester of calculus, you might see this one. So we're going to do an example. I'm going to ask you for this one to find the derivative. This one's a pretty nice one. Some of the ones that you'll get will be a little bit less nice. So keep in mind, we just mentioned the definition of the derivative. It is f prime of x is equal to the limit as, not x, as h approaches 0 of f of x plus h minus f of x all over h. So in order to find the derivative of this one, we are going to find the limit and then we'll do the difference quotient. So you're welcome to pause this and try it on your own, by the way. I recommend that. So we end up getting 2 times x plus h minus 3. That's the first part. Minus my f of x, which is 2x minus 3, all over h. And then if I take that limit, before actually I take the limit, I'm going to simplify as much as I possibly can. So I get 2x plus 2h minus 3 minus 2x plus 3 all over h. By the way, when you're taking a test or quiz, please make sure that you include this limit part right here. Make sure that you include the h. I notice a lot of the times when I'm grading that people sometimes just do the numerator portion of these. So don't forget to do the whole thing. Otherwise, it doesn't actually mathematically make sense. especially on the AP test. Don't forget to do that there. Okay, so then when we simplify this, let's see, my 2x and my 2x are going to cancel out. My negative 3 and my positive 3 are going to cancel out. I'm left with 2h over h, and I am not going to put in 0 yet. You'll notice that I would get a 0 over 0. I would get an indeterminate form. Instead, I am going to cancel out my h's, and that's just going to give me an answer of 2. So 2 is my answer for this. What this means is that this is the slope of the tangent line to 2x minus 3. This actually makes sense. Maybe it doesn't yet, but hopefully after I explain it, it will. So if you look at our original equation, that has a slope of 2. And so the slope of the line tangent to that, which is just going to be like that exact slope, that exact line, is going to be 2. So this makes sense because I'm going to even write that out. I am going to tell you right now that there is an easier way to do this, by the way. You'll learn that probably sometime in the next week or so. So you're going to be really relieved when you see the other way to do these problems. Our second example, we are going to actually find the equation of a tangent line at the point when x equals 2. So the first thing that you might want to do is you might want to figure out what is the y value that goes along with that x value. Basically, I'm going to give you a little picture of this just so you know what's going on. So the graph of x squared plus 2x looks kind of like this. At x equals 2, we are trying to figure out what is the equation of that line right there. So first thing I think that you probably should do, by the way, this isn't drawn perfectly, is you should figure out what is that point right there. Remember from probably Algebra 1, you learned that in order to find an equation of the line, you need a point and you need a slope. So to find the y value for that point, we are, all we need to do is figure out what that f of 2 is going to be equal to. And you hopefully can see that it's going to be 8. So that's a good start. So we now have a point, but the other thing that we need in order to find the equation of a line is to find our slope. And if you look back at your notes, you probably see something along the lines of the derivative is the slope of the tangent line. So in order to find our slope, we are actually going to find f prime, and that's going to be evaluated at x equals 2. So there's a few ways that you can do this next part. I'm going to show you one way to do it. Keep in mind that this is going to be the limit. So our definition again is this: the limit as h approaches 0 of f of x plus h minus f of x over h. One way to make this a little bit easier on yourself is to plug in the x before you actually evaluate this limit. That way you end up having more numbers and fewer variables, which tends to make life a little bit nicer. By the way, popular AP question is they'll give you something like this, and you need to recognize that this is the derivative evaluated at 2. So this is a popular thing to see on the AP test. They don't usually make you evaluate the whole thing. Okay, however, I am going to make you evaluate the whole thing. The good thing is we do have some stuff that might help us out. For example, we already know what f of 2 is. We just found that, so that's something. We don't know what f of 2 plus h is. You can either evaluate that off on the side, or I'm actually just going to do that right here. It's not really very pleasant, unfortunately. you are going to have to do a little bit of math in order to do this. But luckily, I do know that f of 2 is 8, so that's something. Okay, so make sure that you can pause and do this on your own. Make sure that you do use the FOIL method. You don't want to get all this hard stuff done and then forget something that you learned back in Algebra 1. So we're going to get 4 plus 4h plus h squared. That's going to be plus 4 plus 2h minus 8 all over h. So this is still looking pretty bad, but hopefully now you can see some stuff that cancels. Like the 4 plus 4, we know that's 8. That's going to cancel it out with the minus 8. The h's and the two h's, the 4h and the plus 2h are actually going to combine. So let's go ahead and do that. So that gives us 6h. And then we have a plus h squared. And this is all over h. Don't forget this next step. You do want to cancel out that h. You can either factor out an h and then cancel it, or you can just notice that we have both of these terms have an h, so we can cancel them there. So you end up getting the limit as h approaches 0 of 6 plus h. Now we can actually evaluate this. My answer for that is 6. So I'm not done. I did all that work, but I have one more thing to do. This is where the stuff that you learned back in algebra comes in handy. I actually am going to do this next part using point slope form. The reason I love point slope form is because I can just leave it in point slope form and I don't have to go any further. So I know my point is 2, 8. I know that my slope is 6. And then I end up with this equation right here. If you prefer to simplify it out, that's fine with me. It's just an extra step though. You should end up getting y equals 6x, I believe it's minus 4. And you might be able to look at that, that line up here and see that, yeah, 6x minus 4 makes sense. Sometimes it's nice to have a graph to look at, but you don't actually need to have the graph.